In this video, we're going to look at finding horizontal asymptotes of rational functions. We're actually going to begin with a useful fact. Bring my useful fact in. So if y is equal to k over x, where k is a number, then as x goes to plus or minus infinity, y goes to 0. You should recognize this notation from when we used it in the end behavior of polynomials. Now, when we're talking about polynomials, as x goes to positive or negative infinity, y would always go to positive or negative infinity because that's just a property of polynomial functions. However, when we have rational functions, sometimes my end behavior when x goes to positive or negative infinity, the y's will get closer to some particular number. You can see this when the graph is getting closer to a horizontal line, and this number will be the y coordinate that all of the points on that horizontal line share. So if you have a function, say y equals 1 over x, y equals 5 over x, the end behavior, the y's will get close to 0. You can see the horizontal asymptote there. That's a y equals 0. I'm just going to point out some examples. Say 3 is a perfectly good number. 3 over x, that goes to 0. 102 over x goes to 0. And even if, say, you have some power of x on the bottom, 1 over x squared, as long as that's a positive power of x, that's going to go to 0 as x goes to infinity. It is important to emphasize that all of these things are as x goes to infinity. So, one thing that we will be doing, if I have something like 10 over x squared plus 4 over x plus, say, 52. If I have an expression like this, then if we want to consider this as x goes to infinity, I know this is going to go to 0. So we can draw a little line through it. That goes to 0. This goes to 0. And that entire expression would go to 52. And so if this were equal to y, then y goes to 52. All right, so now let's talk about some specific examples of rational functions and how we're going to use that useful fact to find some horizontal asymptotes. So I have a rational function here. Now I can take this rational function and, well, rational functions are all fractions. One thing that I can always do with a fraction is multiply the top and bottom by the same thing. So in this case, I'm going to multiply the top and bottom by 1 over the largest power of x, which is going to be 1 over x squared. I'm going to multiply that times the top. I'm also going to multiply it times the bottom. Then I'm going to distribute. I'll get 8. When I distribute, the x squared will cancel out with my 1 over x squared. When I distribute to 5x, x over x squared is 1 over x. So I multiply that times the 5 and I get 5 over x. And then I have 3 over x squared. On the bottom, I can distribute again. This will be 2. 4x over x squared is 4 over x. And then when I multiply that times 1, I get 1 over x squared. Now we're going to use our new going to 0. I'm going to cross out everything that goes to 0 because since I'm looking for horizontal asymptotes, I am thinking about the end behavior of this function. So So this goes to 0, this goes to 0, this goes to 0, and this goes to 0. So my entire rational function goes to 8 over 2, which is 4. So y goes to 4 as x goes to plus or minus infinity. There is a horizontal asymptote. Oops, I meant to say a horizontal asymptote of y equal 4. Let's do another example. So here I have a function. I'm going to do the same thing that we just did. I'll multiply by 1 over the largest power of x in the entire thing. Now the largest power of x in the entire thing is this x cubed in the denominator. So it'll be 1 over x cubed times, let me rewrite my function really quick. 1 over x cubed times the bottom as well. So when I distribute this, I will get 5 over x, 5x squared over x cubed reduces to 5 over x, plus 3 over x squared minus 1 over x cubed. Now when I distribute on the bottom, I will get 4. 4x cubed over x cubed. The x cubes will cancel and just leave me with 4. Plus x squared over x cubed reduces to 1 over x. 2x over x cubed will give me 2 over x squared. And 4 times 1 over x cubed will give me 4 over x cubed. So now I'm going to cancel anything that goes to 0, I'm going to indicate that. So that goes to 0, this goes to 0. Anything that is a number over any power of x goes to 0. So notice that the entire top this time went to 0. And the entire bottom, well, that's all of this is 0, and I have a 4 left. So that's 0 over 4, which is just 0. So y goes to 0 as x goes to plus or minus infinity. Now, notice I keep saying as x goes to plus or minus infinity. For rational functions, if there is a horizontal asymptote, both ends, the right end and the left end both, will approach the same asymptote. That's not true in general, but that is a property of rational functions. So for this function, there is a horizontal asymptote of, well, it's 0 that the y's are approaching. So there's a horizontal asymptote of y equals 0. And one final example here. I've got another rational function, x to the 5th over x plus 1. I will do the same thing where I multiply each, the top and the bottom, times 1 over the largest power of x. So x to the 5th over x to the 5th is going to just be 1 on top. X over x to the 5th will be 1 over x to the 4th. When I distribute that and multiply by 1, I get 1 over x to the 5th. And now I want to indicate what's going to go to 0 as x goes to plus or minus infinity. It's going to be that and that. Notice now I have 1 over 0. 1 over 0 is undefined. Excuse me. Sorry about that. 1 over 0 is undefined. This function does not have a horizontal asymptote. And not every rational function does. All right. Oop. Oh, sorry. I must have bumped my camera because I was way off screen there. Well, I will also scan these half sheets of paper and put them online so that you can have them to look at. And that is it for this video.